Manish, is it possible to show one YouTube link either at the end or when they ask some question?
We can share that with the students in the chat. You can message that link to me, and we will put that in the live chat on the stream.
Yeah, there is one video by Sunita Williams. You might have seen already. She is explaining how people live in space. One video is there.
Okay.
Shall I send you the link?
You can give it to me on what?
We cannot present in the in between. That is not good idea. In case if it is asked, question when it is asked.
We can try.
We can try at the end when it is needed. I will send you the link.
Okay. Okay.
Just sent a link to you.
Okay. Okay, Puneet sir has also joined.
Okay.
So, we will start because we have started the stream also. So we are right now streaming it live on our YouTube channel also, and students will be watching it across multiple platforms. Okay. So first of all, let me introduce Srinath sir. So first of all, thank you Puneet sir. टाइम देने के लिए और आने के लिए बहुत बहुत आपका धन्यवाद सर. एंड ये पूरी जो लेक्चर सीरीज हो पा रही है ये आपके सपोर्ट से ही हो रही है. एंड Puneet sir is right now he is in Mesra Jaipur campus as assistant professor, and today we have with us Mr. Srinath Ratna Kumar sir, and he is scientist engineer SF in ISRO satellites ISRO satellite tracking telecommand center and telemetry and telecommand center. And I'll introduce our today's speaker because he's going to talk about the human space travel, and we will be introducing you the speaker for the day. And let me just read a few lines about sir. So Ratna Kumar sir holds a master's degree in physics from Bengaluru University, and he has 6 gold medals and UGC NET certificate. He has worked as lecturer in one of the engineering colleges in Bengaluru before joining ISRO as JRF. Later, he joined as scientist in ISRO and worked for Chandrayaan-1 project for the establishment of new facility at Bailalu near Bengaluru. The campus is Indian Deep Space Network lead agency of ISRO for all planetary missions, tracking, command and control. He has played a major role in data ingest, process, archive and dissemination of Chandrayaan-1, Chandrayaan-2, Chandrayaan-3, Mars orbiter mission, Megatropics, YouthSat, and currently he is working on the data archive preparation for the ongoing AstroSat ground systems for payload configuration, data reception and processing in Indian Space Science Data Center. He worked as facilitator for human rating certification of the ground systems for future Gaganyaan mission. And today he will be talking about human space travel also. He is identified as focal person for the SpaceX mission, that is space docking experiment, a very vital part of our future dream of having Bharatiya Antariksh Station. So SpaceX mission docking experiment of ISRO. He played an important role in Chandrayaan 3 lander in data access and display of lander. He was member of rover path planning and contributed for successful 100-meter plus roving of the rover on the moon surface. He is involved in the release of Chandrayaan 3 PDS-4 data for public. At present, he has the responsibility of data processing, proposal handling, and allocation for the ongoing Aditya L1 mission and time allocation member for ExpoSat, our black hole hunter. He is interested in communicating the benefits of science and technology to the public through various platforms as member of ATL of AIM and holds public outreach group called Creative Team for innovative talks covering non-textual, non-syllabus and non-academic knowledge. His other interests are playing ball, badminton, veena, horticulture, and inspiring the students to pursue career in science and technology. He also worked as executive member of Science Committee for establishment of Dr. H.N. Sub Regional Science Center, Gori Bidnor. He has edited 4 books in Kannada as part of Istrak Kannada Rajyotsava and writes articles for science communication. His recent book, Yana, is very well received by science readers and available in Amazon. He is an active member of KST and founder member of Karnataka Physics Association. So thank you so much, sir, for giving us time and providing the opportunity to our students to listen to you and to listen to your knowledge. Thank you, sir. Over to you.
Manish, it's a very pleasure to listen few words about me from you. You are also a distinguished scientist who have contributed to the important missions being in URSC. With your ambitions and other aims in your life, you are also taking up a new role, and I would congratulate you, and I would say best wishes for your activity which you have been carrying out. I would also like to thank the campus or BIT, the authorities, Punit Sharma and many other people whom I may not be knowing. Thank you all. Through Manish, you people have given me an opportunity to interact with the students. Of course, as Manish is also a recognized space tutor by ISRO headquarters, though I am not directly recognized, I have a small what you call education group called Creative, through which I also conduct a little bit of space tutor being inside ISRO. I mean, it's also a great opportunity that ISRO headquarters has given to many people. One of is Manish and myself also we have been doing. It's a very happy moment. We shared dais physically in Delhi. Thank you, Manish, and it's good to be with you. The kind of work which you are doing, in fact, many people say that he is doing good work. I have also personally witnessed. With this initial few words, both on the BIT authorities and Manish, I would love to proceed for my talk. First of all, I would like to what you call submit. This is not my original work, because my original work, as my profile explained, I will be involved in planetary data reception, archival and other things. But this is a part of one work which was assigned to me by Shashi Kumar, who has written in Tamil, and Arvind, who has written in English about the human space travel. I have written it in Kannada, which was very well received. And as a part of that only, I'm going to talk about what are all the difficulties. Of course, I was involved a little bit in Gaganyaan related activity, which we can discuss during your question session. Maybe next slide. Generally, when it comes to the classroom teaching about space, question comes, what is space? So answers could be like this: anything which we see in our naked eye. That is a preliminary answer. It could be small living organisms, and it could be trees, plants, mountains, then space, then aeroplane, beyond aeroplane. Like the various general questions, I mean, answers to the questions will be there. So whatever human eye can see is one way of looking at the space. Over the days, I mean, we can see moon, we can see stars, we can see some planets also. Those who are a very good stargazer or a night sky gazer, you will also include, somebody can say Mercury. Up to Mercury, you can see that is a space. I mean, depends on your capability to look at it. Over the years, technology has developed and it has given our eye a larger capability to look beyond what we can see through naked eye. So it goes beyond our human eye, what we can see. It could be telescopes, it could be satellites, it could be many other what you call technological devices which are designed and developed in recent times, maybe 30, 40 years. If you look at the vastness or the concept or dimension of a space, which is very huge. Last 1,000 years, maybe you can say a small understanding of space. In the last 40, 60 years, or maybe I can say 100 years also is not a wrong thing to say. Maybe after the Galilean telescope, our vastness or our the reach or extent, even the James Webb says up to 13.5 billion light years or beyond, like that we are able to see. That means light is coming to us, but we should be in a position to, that is maybe this way understanding or explaining space is very complicated, but in a simple way, whatever we can say, solar system, galaxy, universe, like these are all generic answers. If I ask or allow the listeners to answer, everybody will give different answers. All are correct. Next slide. So that's how we start our discussion. So I said there may Earth, like for example, on Earth we have a living being. Our life is there on Earth, which is very well known, and we have one way we can say that we have understood the life on Earth excellently. But the question comes: do we have similar Earth kind of a object elsewhere? If so, do we have a life there? What are all the signals that we can send to them, we can receive them? These are all again under the vast subject of a space. These are all the questions every child, even including me, I may say that I know everything, but still this question is still there. Sir, do we have a life elsewhere other than Earth? I can myself ask question. If student asks questions, I should be in a position to answer. Even Manish also can answer, but still he will also have a question. Sir, I know the answer, but still I would like to ask you a question. Do you think that is there a life anywhere else other than the Earth? This is the kind of thing which we didn't get a conclusive answer. These are all part of our space study or astrophysics, astronomy, astrodynamics, so many different disciplines of a space science may come up. I mean, these are all as a part of space. Maybe next slide. So considering that, let's come down back to the surface of the Earth. Whatever we understand in our school or even experimental results which are available, if you look at it also, roughly around 100 kilometer onwards, the air or whatever we say, the atmosphere or the particle density keeps on getting towards the vacuum. Exactly vacuum telling may not be correct, but we can say free space, so it gets slowed down. So even if you watch a launch vehicle like PSLV, GSLV, or SSLV recently, after 100 kilometers, look at that one, heat shield separated or payload fairing separated, like that it will come. At that point of time, if you look at the distance closely, 100 plus kilometer will be there. So assumption or practical experience is satellite will not experience any air force. That's the reason the unwanted weight which was covering the satellite, a payload fairing, is removed. So I can assume that if you cross 100 kilometer, I can say that you have traveled to space. There is a big what you called debate or a contradiction when a private launcher from US, maybe Virgin Galactic, I suppose, when they launched it, I think they didn't reach to this height, or they are very close to this side. That's why they are not space traveler. Somebody, challenged that no, they are space travel because they. So generally, this is known to us in terms of classroom understanding of physics. But there is one important word called as a Kármán line. They use it. Anything above 100 kilometer, Kármán line, they say. If you have crossed the Kármán line, you are a space traveler. So if I go to another aeroplane may can go up to 13 kilometer or even beyond. A stealth plane can go more than 20, 30 kilometer. Some objects can go like balloons, like different heights, like sounding rockets can go up to 50, 60, up to 300 is there. When we started, it's 50, 100 kilometer. So depending on the different height, if a person is traveling in that, you are called aerospace. If you are an aeroplane, aerospace engineer, you are not astronaut. If you are traveling in an aeroplane, 30, 40, 50 kilometer, or even a stealth plane, you are not astronaut, right? So if you cross the Kármán line, we can call you as a space traveler. So what we have studied in our classroom is troposphere, stratosphere, mesosphere, thermosphere, exosphere. Look at that. Exosphere and beyond that, like satellites you see there, satellites are all there. So night sky, if you see many what you called the meteoroids, all those things you can observe in the night sky. That all comes under your mesosphere. Where are the aeroplanes? Roughly around 13, 15, 20 kilometers. So if you have understood this, now you can say who is traveled. Like space tourism is coming up in a big way all over the world. People want to take to certain height and bring back to give the feeling of what you call as gravity, natural gravity. But there are other things which we will see in the subsequent slide. Next slide. So any satellite means what? Which should be beyond this. So in this domain, compared to other countries, India also is very well matured and has demonstrated its capability going beyond this particular height up to 600 to 1000 kilometers, which we call as a low Earth orbiting satellites, 36,000 kilometers, which we call it as a geostationary satellite or geostationary orbit, where we have placed innumerable number of satellites and demonstrated our capability to observe the Earth, to provide the communication, to provide the TV, to provide various other services, right? Same way, we have also crossed around 3 lakh 85, roughly I can say 4 lakh. We have gone to the moon. We have taken the images of the moon. We have even gone to 250 million or roughly around 150 to 300 million kilometers, which is a Mars mission. We have gone there. So this is the extent to which we can go. I mean, of course, if you ask me the NASA missions, it has gone beyond our Pluto or crossed that our particular Voyager 1. Of course, what I'm trying to bring out in this slide is the moment I say satellite, it has an observation of a target. In case of a socially application oriented satellites, I want to observe India, I want to observe my cities, I want to observe my agriculture fields, I want to observe recent disasters which has happened, I want to observe my dams or my what you call water bodies, I want to observe the cloud coverage on India. So if I observe this satellite, as a scientist, or like Manish was a scientist who was working in your satellite center, his job is to make a satellite to observe the certain thing. Now there are various other departments which comes into picture like agriculture, meteorological, urban planning and development, various other ministries, departments, they use these particular data and use it in the best way what we can serve. So that's how satellites are being more effective in terms of water management, in terms of weather forecasting, in terms of cyclone monitoring. Even post-disaster also, satellite pictures are being used to rebuild our whatever damaged places. This is the various next slide. Various applications of satellites. That too, when you go for a geostationary satellite, kind of a communication satellite, you need satellites for healthcare. You need satellite for television. You need for sports industry, where you have a lot of events are happening like Olympic or like World Cups. Everywhere satellites are playing very, very important role. Disaster and mineral mapping, there are certain telecommunication and teleeducation. Even in terms of a poorest of poor, fishermen also are benefited by the satellite application to go to a particular location to do fishing. So I'm trying to give you certain overview of applications of satellites, where you name a field, any field you name a field, where either directly or indirectly satellite has a role. It is helping our humanity, it is helping our society to do a better living or to do a better our activities. Next slide. So if you are having satellites like this, which can do whatever you want, that too in the current scenario of artificial intelligence, machine learning, robotics, so many advanced technologies are coming. In spite of all these available things, do you really want to travel to the space? Let's assume before 1969, anyhow that slide will come. So what could have made them to go to? There are reasons I will explain. Really, do you want to go to the space? This is a question. If you ask this one to Manish or myself, immediately we will say no, sorry, yes. We are very optimistic. We want to do something. The moment you say no means no, that is not the scientist or any general. Even there is a huge demand in India that why India is not entering into, after Rakesh Sharma, why India is not entering into this particular astronaut domain. Why now you are saying it, I will also talk about it. So what is the basic thing is, you need to travel. Why do you need to travel? Somebody will say, sir, अर्थ के ऊपर बहुत ज़्यादा population हो जाएगा, तो इसलिए हम जाना. I mean, lowest of the lowest type of answers. Let's look at it. So population may increase. I want to live somewhere else where I don't want to be in this. Okay, that may be a reason. सर धरती के ऊपर बहुत सारा पानी खत्म हो जा रहा है, बहुत सारा मिनरल्स खत्म, आई वांट टू गो टू अ डिफरेंट प्लेस वेयर आई हैव अ लग्जूरियस थिंग, दैट इज आल्सो ट्रू. Then earth may become at some point of time, because of meteoroid or because of some other objects, asteroids or some other dangerous bodies may come and hit earth moon system, we may die. So I want to preserve the human species, or I want to preserve humans, so इसलिए मैं एक बंदे को लगा के उधर भेज दूंगा, both male and female, ताकि मेरा, these are all crazy ideas are there. Whatever may be the crazy idea, why you want to travel space is your sheer curiosity. You are ready. See, Elon Musk once said, I want to live, I mean, I am born on Earth, I want to live on Earth, I want to die on Mars, he is telling. उसका गोर ही मतलब क्या बोलते हैं हम, the cremator should happen in Mars, that is the kind of a statement. So because of simple curiosity, everybody is interested. Whether I am selected or not selected, the moment opportunity is given, you also want to go and sit in a rocket as a aeroplane में जाकर बैठते हैं ना, like that you are also interested. Even a physically handicapped person, if you are allowing him to travel, of course it is possible. In future you will see, right now there are certain restrictions to select an astronaut. In future people want to do like an aeroplane jata hai na, like that everywhere chance tak jao aa jao. That is the kind of what you call target or imagination people are looking at it. So what I would like to say, only reason is man is curious and he wants to explore whatever may be the reason, whether resources hai ya nahi hai, even for crazy reason also people on next slide, crazy reason also people want to go there. That's fine. You plan to go to elsewhere, wherever it is, whether it is on moon, Mars, beyond our solar system, whatever. What do you need? What are the basic requirements which you need for a healthy, a better, a good, a return guaranteed space travel? Means you need to have an advanced rocket system, management of the gravity or weightlessness, and certain other skill sets. जैसे हम इधर लीव करते हैं ना, in gravity live करने के लिए, if you want to live in a gravity, you need a better skill sets are required. Safe and soft return technologies चाहिए. Space debris होगा, space dress होगा, उसके ऊपर थोड़ा knowledge होना चाहिए. And certain psychological stresses and environment management करने का training होना चाहिए. Life support system बोला जाता है. It will be similar to ICU kind of a thing. We will discuss that. That is essential. There are certain other technologies to build rockets in space itself. Suppose if you want to extend your travel or you want to come back, certain reasons due to certain contingency, then space food is a very, very essential. If you are going for a day or a half a day or within few hours, food can be managed. If you are going for a longer trips, you will need definitely space food. Since we are very curious, we want to do agriculture, start doing agriculture. We want to prevent the space accidents. So उसके लिए एक नया technology चाहिए, space forensic field बोला जाता है. Then if you are traveling in space, you will have a medical complication, so you have to have a on spot or in situ or on board space medicine चाहिए. And there are so many other scientific research people want to do. Anything human does is to do improvise our current way of living, current way of thinking. Scientific exploration is the only reason. As I said in the previous slide and in the current slide, if I travel elsewhere, I want to do something which can improve the life on Earth. If I go see, even for corona, even for many diseases, people are doing testing of medicines, next slide, in the space. So if you are traveling to the space, these are all the basic motto or basic wish or whatever may be your ambition. So these are all required. So just to have a little bit at a small history of rocketry, Indians should be very proud that there are two important regions of India. If you come to the northern India, Awadh, where less evidence is available. Awadh means the current Lucknow and Lucknow around region, olden days, where there are certain what you call citation or inscription or some references stating that they were using certain rocket like Agni Band bolata hai na, fire arrows like that. But scientifically or by evidence, even now, few months back, few years back, a lot of evidence is found. For the first time, rockets, we cannot use the word rocket in strict principle, but we can say Agni Band or bamboo fire rocket, some kind of rocket is not a correct word. Of course, Deepavali maybe we will use rocket, but still there were certain fire arrows which were used by the Mysore kingdom against the British during first, second and third Anglo-Mysore India. That was the first evidence. Well before these evidences, There may be other evidences where Mongolians, when they invaded India, they have used rockets like that. All history is available, but we need to do a lot of research in this domain. When it comes to the Indian context, one is in a Mysore kingdom, another is an Awadh kingdom, where certain Mysore kingdom is well established. There is a strong rocket, what you call rocket word. Don't get misconfused. Fire arrows, Agniban, like that you think. The moment I say rocket, don't go to PSLV, GSLV type in your mind. Limited one where you can fill the gunpowder and fire it, it will go and kill some enemies. That's kind of a thing, which was well established. First in Mysore kingdom, they were using bamboos. Later by the Tipu Sultan, he replaced it by what we call as a iron. Karnataka was very good at iron and steel manufacturing those days. Blacksmiths were very good. They have manufactured and used it. But when it comes to the Chinese, there is one very good evidence that there was a chair को चार तरफ gunpowder मिला के rocket लगा के उसको lift off किया था, बाद में वो मर गया. There are so many historical stories are there. Please next slide. So you can study it. But scientifically, what you called as a scientist, if you want to say, these are the two men we should be grateful. One is Von Braun, German scientist who later moved to USA. Then other one is Sergei Kirillov. He was the Russian. These two people can be attributed as the father of rocketry. The word rocket here, I will also give the distinction between rocket and launch vehicle. Of course, you can say rocket or a lift-off vehicle. So the difference between missile and rocket, if you are using rocket for a constructive purpose to launch some object to the space for studies, that's a rocket or a launch vehicle, you can call it as. If you use it for a destructive by having certain weapon or a bomb or in the head of a rocket, it can be called as a missile. Of course, when they started, it's a missile. Next slide. It's a missile development only. Later, it was used for a rocket. Maybe in future, we will slowly use the word launch vehicle. Rocket or a launch vehicle, try to understand same thing. We will not be dealing anything more about the missile. That is a different domain, strategic domain, which we will not be addressing. This is how it looks. You should have the place where you can place your civilian application oriented object called as a satellite in this case, where it will be covered by heat shield. Then you will have multiple stages. It can be single stage to orbit, it can be two stage to orbit, it can be solid, it can be liquid engine. Depending on, you will see n number of I can give one small assignment to any interested students. List out all the operational rockets as on today. Write down their different stages. What is the fuel used? First stage solid, second stage liquid, third stage. That will give you fair understanding about how the rocket and how it works. Maybe it's a small assignment only, one table they can write. So this is a generic example I'm giving. It belongs to some rocket, but don't worry about which rocket it is, all those things. What's the overall weight of the rocket? What is the load it can carry to the orbit? Next slide. This is a general terminology, we talk about it. So this is how I told you the two people, they moved to the US and Russia. Then we call it as in our the world history of rockets or a space. There is an unfortunate term, we have to use it. It's called space race. Today, we are not in favor of any space races, whether it is India or any other country. But unfortunately, last 30-40 years, this has happened between the United States of Soviet Russia, USSR. Currently, it is Russia only. Those days, it is USSR and USA. Whatever may be, it has developed a lot of technologies. People may remember this as the first satellite, Sputnik. Even now, we celebrate World Space Week. Maybe Manish will be doing 1 week long program on World Space, maybe in October 10 plus or minus days. That is the first satellite. It's sent only beep, 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 beep signals using certain UHF, VHF antenna. Then Sputnik 2. Next slide. Like that, America also started doing a lot of rocket and satellite. But in the beginning, Russia was very, very much ahead of it. They started sending even animals also. Maybe you are aware of these animals. One is a Laika dog. So many animals, fruit fly, so many things they have sent to the space. Next slide. As a part, it's a practically or official, it's a space race between the United States of America and Russia. Maybe today, if you look at it, it looks ugly, but those days, it is the way of life. Those days, they have done it, and a lot of new technologies have emerged during those days. Even now, we are all beneficiary of space. So if you look at it, first person to go to the space is Yuri Gagarin. Generally, 1 mark questions will be there when we conduct space quiz. We will ask this type of questions. So recently we did it in Lucknow. Many students really answered excellently. So then the satellite Explorer was the America's launch, first launch. Generally, in America, they call it as astronaut. In Russia, they call it as a cosmonaut. Nowadays, China is also performing excellently in this domain. Of course, India is equally good, except in the human domain, which we are still working on it. They call it as a taikonaut. India may call in future, that's not officially declared, but still, Vyomonaut, Vyomomitra, some terminology is being floated. You can read about it. So this is how the space race those days. Next slide. Who was the first woman astronaut? This is a general question we generally ask to everybody. Immediately they will say Kalpana Chawla, somebody will say Sunita Williams, because for us they are the first woman astronaut. There was a lady who is a farmer's daughter in Russia. She was very, what you called, exponent or skilled or very well trained in handling the parachutes. Parachutes handling. That's the basic reason she has been selected as a astronaut. She was first sent to the space by the Russians. Russians. She is Valentina Tereshkova. One small incident is, see those days it was a mostly men-oriented industry. It is. Some people even now complain that the space is only male-dominated business, but not so. But there are so many women astronauts. She has to wear men astronaut dress only. At that time there was no female astronaut dress. Now you have everything. We here in our India now, मैं जब कोई woman what you called achiever, when मैं पहले बार कॉलेज को गया, कॉलेज में टॉयलेट ही नहीं था, जब मैं जाने के बाद टॉयलेट बना. But for Valentina Tereshkova also there was no what you call female astronaut suit, astronaut dress. So she has to wear men, and she has traveled to the space. She has successfully come back. When she was coming back, even though she was an expert of parachute, they were supposed to land at dedicated site. She did not land. She has just, hope my voice is audible. Is my voice audible?
Yes,
There was some,
it's audible. It's audible.
yeah, fine. When she was supposed to land at certain place, what you call dedicated place, she did not land because of certain technical difficulty. She just landed, light crash landed, not heavy crash landed, mild crash landed into a farmland. Okay. So in the farmland, people have seen. After seeing her, they immediately complained to local people, and some people went. Then our space industry people also went and rescued her. And in the next day in paper, it is coming first woman to travel to space, Valentina Tereshkova. Like that, a old mother is reading in news magazine. She is the mother of Valentina Tereshkova. She was not even knowing that my daughter is getting trained astronaut. She is going to fly to the space. She is going to achieve such kind of a. That was the kind of secrecy being followed during those days in the space industry. Today, if you ask me, India also has opened up our space reforms. America has opened up space reforms. People want to collaborate. People want to work together. That's the kind of situation where we have moved. Next slide, please. Where we have moved is what we can experience. If you were there 40 years back, I cannot give talk like this about space with so freely, so very talking online, all these things. Okay. So space race continued. Later, the American President Kennedy has declared that, see, after having achieved every step you take, Russia is a first satellite, first animal, first what you called living being, then first woman. So many firsts are there in the Russia. Russia is a master of space industry. America was also equally competent enough. They wanted to say the first one, chalo hum chale jayenge, moon ko jayenge. So can you imagine it? See, of course, they were also struggling. Lot of technologies they were establishing. President has announced we will land on the moon. So that they successfully achieved. Whatever missions I have shown is Gemini, Apollo, all those missions are there. You can see a photograph of Barack Obama after maybe that is 50 years celebration. There are three important people, Buzz Aldrin and Collins, Neil Armstrong. You may be knowing the story that Neil Armstrong was the first person to step down a giant leap for a mankind. Something, there is a big statement, a small step for a giant leap for the mankind, something. Please, next slide. So that's how they also became successful in reaching out to the moon. There were so many other success stories of the Americans as well as Russians. You can see these are called the human rated or the vehicles which can carry uh, man or astronaut or men and women both. We'll say astronaut is a generic word, so they can carry to the space. Next slide. I can discuss slowly one by one. These are all rockets. You can as I told in the beginning, someone can figure out the launch vehicles only to carry material. We call it as a cargo. Launch vehicle to carry only life or human beings or astronaut is a crew missions. You can also list out those things. What are the available things? This is how the rocket looks like that. Next one, next slide. This is the some schematic diagram. Generally, when you say a crew mission or an astronaut mission, you have to have a two important components called as a landing module, crew module. So crew module people will be there, or service module people will have certain, like we are living in a house, there is a hall where everybody will sit and do all those chatting. There is a kitchen and other accessory rooms for our convenience. Like that only, even in a manned mission, you have to have two important modules called crew module and service module. Just to show you some schematic diagrams where you will have a service module, command module, lander module, all those things. Next slide. These are publicly available information. You can have a look at it. How Apollo spacecraft was looking. So this is how they made their program successful. They can carry 3 or 2 astronauts to the space. I think more than 11 or 12 people have landed on the moon. Next slide. Maybe here you can. This is another what you call the crew module designed and developed by the Russians. Next one. Some pictures only are there. These are more such things. Just have a look at it. Only here the different crew module and service module, how it was developed. Next slide. Yeah, generally it's a general profile how human rated vehicle should operate. Main criteria is what I want to have a safety of my what you call astronaut or a personal who are inside. Lifts off, go to the dedicated orbit, and it should come back also. In the beginning, they did the many experiments, thousands of experiments they have done, sent to low Earth orbit around 400, 300, 500, somewhere whichever is convenient, then bring back safely. Even whatever the Kalpana Chawla, which we have seen as a disaster, it was also around 400-kilometer mission only. Return time, you have faced the problem. So this is a schematic profile of any particular human missions. You should go to the space, achieve your target, and come back it. Okay. So till 1975, Apollo vehicles were serviced. Later, space shuttle started. Shuttle, there are so many, 6 are there. I think Challenger, Columbia, Endeavour, then Enterprise, like that. So 6 vehicles are there in the Discovery shuttle. One interesting story here is America. Maybe if you recall, during lockdown, there was an interesting mission by the SpaceX. After the Kalpana Chawla's experiment, no, America stopped all these 6 vehicles as a part of space shuttle. They purely dependent on Russians vehicle. I have shown in the previous one. Soyuz. Next slide also I will show you. They completely, maybe this one, gray colored one is a Soyuz. You can see there. Soyuz is more, come back to that slide. That is a Soyuz. Next slide also, that photograph will come, I will show you. Soyuz is the most trusted, most reliable. So after Kalpana Chawla incident, somewhere around 2001, I believe, somewhere October, November, 2001, I think, they stopped all their human carrying launch vehicles. They were purely dependent. Just look at it now. The story I started is space race between USA and USSR. Of course, rivalry or competition or race, whatever may be. Now, last 20 years until SpaceX came, America was blindly or completely dependent on Russian Soyuz vehicle. See, in science and technology, collaboration is very, very important. So to keep our space station active, they're dependent. But anyhow, in 2020, SpaceX started a Dragon Falcon vehicle that's called Launch America program. You can see a lot of videos are available in YouTube. Now, America is developing a bigger program called as SLS, Space Launch System, where Artemis program is planned for space mission to the moon, gateway program, and land on the moon and make some habitat on the moon. That way we can see it later. Next slide. This is how the last 20 years it happened. This is the schematic diagram of human-rated vehicles, where mostly Kalpana has flown, Sunita has flown, whom we know, many other astronauts. I think you should remember, this is also another question which I am also trying to get it. To my understanding, around 620 plus 24, 25, exactly I am trying to figure out number of astronauts so far trained, flown to the space. For example, India has Rakesh Sharma as a flown astronaut, whereas Ravish Malhotra, Radhakrishnan, V.V. Bhatt, and current 4 astronauts which you have seen in the news media, they are trained astronauts. India has only 1 flown astronaut, that you will see it later. Like that, there are around 620 plus. We are trying to bring out that list. It is available in Wikipedia. It is available in NASA's what you called Humans in Space link, where A to Z they have given the astronauts of America only. All over the world, how many number of astronauts are there? Like that, we are trying to bring out. So this is how human-rated vehicle will look. Next slide, please. I will not go into the details of each one. So this is an interesting thing which we should understand. It's not only human sending. There are certain repair missions. We call it as a service mission. Somewhere around 400 plus only, the Hubble Space Telescope, last 25 or 27 maybe, by now 27 years or 28 is over, it is successfully operated, Hubble Space Telescope. As I initially told, no, the definition of a space is now enhanced or increased because of this particular telescope, Hubble Space Telescope. They understand there are so many other telescopes, Chandra, Kobe, there are so many other telescopes which have looked at the astronomical objects, and our understanding of the universe has enhanced. Hubble Space Telescope plays an important role where you have a deep field view camera in that one, which will look at the in optical regions. This got into a problem. Right now, you see, I am wearing a specs. Okay, there is some problem in my eye, like Manish is wearing also. So if we remove it, our performance will reduce. We cannot see the fonts or we cannot see images. Blurriness is there. So when for the first time Hubble Space Telescope was launched, the optics, no, it had a problem. So how to solve it? Then the shuttle people and American astronauts and the mission scientists found out a way that is called as servicing the mission. Since International Space Station also in the same, somewhere around the same orbit, the Hubble Space Telescope also same orbit. You can go to next slide, where they thought that we can repair it. Think about the challenge and what you call daring and dashing thinking. Simply studying physics is not alone enough. You have to use that physics when you are on a road, on a ship, on an ocean, anywhere in the sky. So they thought we should bring the telescope to our space station. Anyhow, there was a Canada arm was there. I will show you those space station parts. They docked it. Dock means attaching to the main port. Docked it and replaced. There are 5 service missions. They have replaced the optics. They have replaced the electronics. They have replaced the onboard memory. They made sure that it has worked up to 25, 27 years. Even now it is working. Anyhow, James Webb Space Telescope is going to do much more work than what Hubble Space Telescope. I am trying to tell you, the human space mission, this is one of the best example to say application of not only, see, robotic can be there, but here person should go there, look at it, inspect it, repair it, make sure that it is working. So human presence is very, very essential. There were a lot of robotic technologies available. They could have done unmanned repair, but 5 times missions, service missions were carried out where astronauts have gone outside. That is called as extravehicular activity, repaired it. Next slide. That's how they have done it. I was talking about this vehicle where Americans more than 20 years depended on it to send humans to the space. Anyhow, they have, next slide. This is a Soyuz by the Russians. How does it look? There is a different profile. I have shown you the earlier profile is a Discovery profile where it was coming and landing on an ocean, landing on a runway or landing on an ocean where a Dragon and SpaceX is doing. This is Russians where they will land on a desert. Next slide, they will see one more picture. When you land on that, this is how people will be sitting inside, jam-packed, closely. Even today, this is the profile. If you are seeing Soyuz liftoff, I think 4 days back, a cargo mission went from the Russian spaceport. If you are sending a crew, it will be like this. Crew model will be like this. Profile is like this. They will have a primary landing site in desert. Russia is blessed with a huge desert, like an ocean only, desert ocean. So there they will land less than 0.5 meter per second or even close to that one, so that there will be less impact on the people who are inside. Most safe, most reliable. To my knowledge, it's 0% accident rate in this what you call Soyuz. Next slide. This is what I was talking about, the America's Launch America program, where after the disaster of Columbia space shuttle where Kalpana we have lost, they stopped for a while. They restarted using the private companies, SpaceX. This is a Dragon module. This is a testing of the done. Next one you see. This is another astonishing thing is he has made entire world really astonished, because the first stage is coming back, not one rocket, both the rockets are coming back and landing. जैसे हेलीकॉप्टर आता है ना, हेलीकॉप्टर के अपना लॉन्च का एक पैड होता है, H लिखा होता है, H के पाके खड़ा हो जाता है ना, like that. This is the kind of development there. It's a reusable launch vehicle. Of course, many countries are also doing this kind of a development. Maybe even in India also some efforts are being progressed. So this is one thing which SpaceX, Elon Musk has made entire world really astonished. This is currently very operational. Same vehicle 15, 20, 30 बार use किया गया है, and it's very safe. Next slide. Inside, this is space stations. When it comes to the history of space stations, Salute 1 was the first space station. What do you mean by space station? It is an orbiting laboratory for certain specific scientific research to make people live there, carry out certain experiments, and come back. Let's say it should be like a go, safely reach there, then come back. Salute is, many Salute versions are there. Mir is a Russian space station. Next one. There are so many other space stations. Skylab is one such station. We are very young. In our childhood days, if our fathers, maybe like Manish father, my father, and any other audience, they may be aware, 84 or somewhere at that time, in India also there was a radio alert. In the radio, they have given alert, ki Skylab is falling to the earth. Everybody be careful, like that. There was an alert. Of course, that is not so, but it went to, and when it is brought back to the earth, it entered into the what you call as the ocean. It does not affect any. Even now and then we get certain alerts that object is falling. It may fall on your land region or civilian region or human populated region. But mostly, whenever we are bringing back any space debris, carefully they are bringing back to the ocean or no man's land. But this Skylab had that particular news. You can Google it. What is Skylab news on India? So it is there. Somebody has explained to me, a senior ISRO scientist, when he was young, he got this type of a news. Next slide. The left picture was trying to show in the space station how many people can live. I think so far the highest number of people lived at a one point of time. Currently, people should be aware that there are 9 people are living in space station of International Space Station. There are 3 people are living in Chinese space station. So 9 plus 3 is around 12 people are lived in space. Whereas in International Space Station alone, there are around 13 people lived together same time, roughly around maybe 1 month or somewhat like that. Because every 6 months, the shift duty changes. One team has to leave the space station and go down. The other team will come well before shaking, what you call handing over will happen. That's trying to show the left picture where mostly you can count the heads, you will find out. Next slide, please. These are the overall space station, Salute, Mir, Skylab, International Space Station. I think I have to add Chinese space station, which is called Tiangong. Tiangong means heavenly abode or heavenly, what you call Swargagar, or what we can say, house in a heaven, like that. They use that word. Ours is Bharatiya Antariksha Station. Space station is India's. In future you will be seeing. Currently 2 space stations are operational, International Space Station and Chinese Space Station, mostly around 400 plus orbit. Both of these stations, if you want to observe in the evening, if cloud is clear, you can use app. Please note down, anybody who is listening, ISS Live or Space Station Live, one application is there, where they will point out Chinese space station also, even some satellites also they will point out when it will rise. Go to Play Store, type ISS Live, you can see it. Next slide. These details I have given. This is the space station overall look. How does it look? The more than 25 years old, continuously human present, operational, no issues. Of course, some minor issues were observed. They have resolved it. It is beautifully operating. Lakhs of experiments have been carried out, both within inside the space station as a research laboratory, outside also for certain monitoring. They have done a lot of experiments. Next slide. It is of the size of we can say football stadium. Just imagine a football stadium अर्थ के ऊपर 400 kilometer height में घूम रहा है तो, and it is very well equipped. 13 people I said, even more than 13 people can live there up to a month, 6 months, up to a period of 6 months. This is the exploded view of International Space Station. How did they build? By sending each and every small module. Zaira is the first module. ROSA, they say roll out solar array. Whatever you are seeing, that gray blue color one. It हमारा जो घर पे होता है ना चद्दर और we say mat, चापे in we Kannada we say. It rolls out, right? The moment you say like that, the solar panel also rolls out. One interesting experiment when Thomas Pesquet, who was a European space astronaut, who came to Bangalore, he narrated this story. So he was on a job on ROSA. ROSA means roll out the solar array, rolling out solar array. When he was doing that experiment, his helmet, whatever helmet, there one light will be there to see it. Because during, it's a long hour, 10 hours, 12 hours, 20 hours, it will be night and day. तो उस टाइम पर उसका जो हेलमेट के ऊपर एक लाइट टॉर्च था वो थोड़ा टूट गया. He was not able to look at it. Whenever he looks at it, light also should be there. So what he explained to me is, it was not planned. When you break, see, every event in space station, it is planned in ground. There will be contingency procedure, there will be secondary plan B. He was not aware when this is broken, how do I do it? Because gloves will be very big. He cannot put on through a night pole. The moment he saw some extra unused wires there, space station, he used that space station tied onto his head. जैसे अनिल कुंबले during his one of the test matches उसका head टूट गया था. So he was with a bandage and bowled it and he got some 10 wickets something. I told him, sir, you are an Anil Kumble of space, like that I told. He laughed at me. I explained him Anil Kumble episode also. So that's how people plan and work on space station. There is an analog space station in the ground. People do every experiment on the ground. Then only they will direct the space, next slide, direct the astronauts to do that one. This is one such inside and outside. How do you look? Inside space station, gravity, of course, outside also is not there. How he is looking inside a space station. When you are doing extravehicular activity, how they will be looking at. And the dress, you look at it, different dresses should be there. Next slide. My time is also exceeding. I should go fast. This is one of the another important field where, why I am putting this area, India, we have to develop manpower. What you call as a space forensics. We have a criminal forensics or police forensics, वो सभी है हमारे पास. But space forensic, aerospace forensics बहुत कम है. We need to develop those who are mechanical engineers, electronic engineers, either at PG level or higher studies. You should get into this type of a domain. Of course, in VSSC recently, one department is there which looks at space debris and its impact. What is the danger? Suppose if it falls on Jaipur, on debris, किसी के घर के ऊपर गिर गया तो police आके करेगा. That is only police forensics. But there should be one space forensic experiment also. Of course, from PRL, some people have gone. This domain has to be improved. I would like to bring to your attention that, of course, whatever I have shown is accidents in space is very, very concerned. So the moment we send humans to space, it is our duty to bring back them safely. Now we are all struggling, or we are all worrying about Sunita Williams, right? We will talk about that also, Boeing related problem. But anyhow, we lost Kalpana Chawla and we lost these three Apollo 1 astronauts whom you are looking at it. Challenger disaster, this was another setback to India's space program. During Challenger disaster, 2 people were trained to become an astronaut. I told you the names, no? Radha Krishna and some VV Bird. After this Challenger disaster, government of India thought, okay, or maybe that side also they may said no. We stopped it. Later, 2003 onwards, our work also started progressing towards manned missions. Next slide, we'll quickly finish it. What type of a space dress or a space suit is needed? जैसे हम T-shirt पहने, Manish shirt पहने, this is good. Inside space station, you have looked at it. That also should have certain criteria is there. But when you are launching, when you are inside, आपके temperature, sweating, then so many other body fluids are coming out, susu hoga, toilet hoga, so many problems are there. Of course, toilet facility will be there, but when you are working for 10 hours, 15 hours, you need to have a pads. जैसे हम बच्चों को पैड पहनाते हैं ना, like that astronauts will wear a pad. उधर ही सुसु कर लेते हैं, it will not affect, hygienic का affect नहीं होगा, then they will change those dresses. Maybe 1 year back there was a news report saying that space पे कुछ इन्होंने junk फेंक दिया. Whatever can burn out in space, when they are coming back from space station, they'll throw it. उसमें pad, but kapda, whatever you don't need to bring back to earth and reuse, they will throw it in the space. वो उधर ही burn होके हो जाता है. Space suit is an important thing. Next slide, where we need to develop. See how do they wear it, how do they test it. Space suit, हम gloves पहन लिया तो I cannot do like this, I cannot do like this, I cannot do like this. So many difficulties will be there. How to handle certain skill sets, they will give training. Next slide. Maybe from now I will move a little bit faster. There is one more important concern is called as chicken leg syndrome, they say it. The moment you see, we are at Earth, it is around 9.8, 1G we say it. The moment you go to the higher altitude, no, gravity बहुत कम हो जाएगा, microgravity बोला जाता है, zero gravity बोल. That time our fluids, our body fluids will all move towards head. तो पतला legs हो जाएंगे, body head हो जाएंगे. This is called as a chicken leg syndrome. So to avoid this one, you have to do certain next slide, counter exercises where to keep yourself fit. And also when you are launched, no, you cannot be straight sitting like in our train में, bus में बैठते हैं ना, like that you cannot sit. The moment you sit and launch, no, with high speed, आपका backbone break हो जाएगा. So there will be huge pressure on our backbone, and so you have to horizontally sleep. Next slide. And sometimes what happens, so your backbone also expands because of the gravity. So either आप 160 सेंटीमीटर है, स्पेस हो गए तो 165 सेंटीमीटर हो जाएगा. जो भी क्या बोलते हैं ड्वार्फ आदमी है, प्लीज गो टू स्पेस, आप लंबा आदमी बन जाएंगे. बाद में वापस आने के बाद यू विल बी ड्वार्फ ओनली. डोंट थिंक दैट यू विल बिकम taller when you go to space, but there will be little bit expansion. Certain tests are being conducted in space. आपका dental health is very very important because of the gravity. Some other problems will be that checking heartbeat, blood pressure checking, blood flow also affects. These are all what you call health challenge. Next slide please. Yeah, also you have a lot of what you call pressure on your muscles, also on your bones. Bone decay will be more. The numbers are given, kitna bones decay ho jata hai bolke. It is essential to take certain what you call calcium diet or bone strength enriching diet in space also. Next. To overcome all such kind of a problem, you see Sunita Williams doing certain exercise, some another astronaut who is doing treadmill. Every day they have to do lot of exercise in space also to keep up their physical fitness, calcium intake, bone strength, muscle loss nahi hona chahiye. So many other problems. To overcome that, फिजिकल एक्सरसाइज इज मस्ट. जनरली अर्थ के ऊपर मैं लेजी हूँ, एक्सरसाइज नहीं करूंगा, फिर भी चल जाएगा. यू कैन बी हेल्थ एंड फिट. इट्स नॉट करेक्ट वे टू से, बट यू शुड डू एक्सरसाइज, योगा, वट एवर बेस्ट पॉसिबल. स्पेस में कंपल्सरी वी शुड डू, अदरवाइज बोन लॉस, मसल लॉस, अदर प्रॉब्लम्स विल बी देयर. नेक्स्ट स्लाइड. देयर इज वन मोर सिंड्रोम. हम जब गाड़ी में जाता है, कार में जाता है, कहीं भी जा रहे हैं तो वी विल गेट वॉमिटिंग, राइट. Some students or some of our mother or especially ladies will have that vomiting syndrome. Similar syndrome is possible as soon as you enter the space station, which is called space vomiting sickness, where they will also train or they will clean up those things. Next slide. This is one more problem which is encountered. Of course, there are certain radiation effects on humans when they are in space, on electronic gadgets or electronic components. It may degrade because of high energy particles, because of high energy electrons and protons. So you have to design your cloth, you have to design your electronic equipment to protect from the radiation. Next slide. Protect from the radiation effect. The moment the radiation effect, it is found that it is more affecting women astronauts than men astronauts because of various reasons. As you go different heights, space radiation effect is more, is what being discussed in this slide. Next slide please. So if you are living in space, there are various challenges are there. Physical challenges, environmental challenges, mental challenges, even personal challenges are there, which we will be discussing in few minutes. Next slide. What are the physical challenges? How to sleep in space? घर पे जब सोते हैं हम, we will say that please put your head towards the south. Those who are vastu conscious people, put your head towards the east. Sir, मैं कल सोया था, नींद नहीं आया, so I have to change my direction, my bed. These are all you have. I mean, everybody has this kind of a difficulty in your bedroom, right? Your bed should be good, so आपका pillow should be good. Pillow change हुआ तो नींद नहीं आता. Things. Many people have that problem. आपका एक specific bed sheet होगा, आपका. These are all problems in sleep in the I mean surface of the on the surface of the earth. But on this space कैसे सोए? उनको कोई north south direction नहीं है, ऐसा कोई. They have only sleeping bags. बैग के अंदर जाना है, जिप लगाना है, टाइटली दे हैव टू टाई टू इट and one जैसे हम क्रेमेटोरियम में लगाते हैं ना, ऐसे एक बड़ा बॉक्स होता है उसमें लगा देते हैं. Like that they have to sleep. I think I was telling to Manish that there is a small video by Sunita Williams. He will be sharing in chat box. You can have a look at it. It's 8 minutes. She will nicely explain how to sleep, how to lock yourself. And moreover, sleep means what? Night. 12 घंटे के बाद, दिन के बाद 12 ना रात आ जाता है. But there in space station, every 1 hour, 1.5 hour night हो जाता है. So from ground there is a different team. They will guide to astronaut. भैया तुम्हारा काम इतना हो गया है. Now it is time for you to rest. So they will dictate from the ground that you have to take rest. So sleeping is one problem. The moment he starts sleeping, no, it is a huge laboratory. बहुत सारा background noise होता है. You cannot easily sleep. I was telling, even if small fan is rotating, some people cannot sleep. They will say switch off the fan because I want a quiet, calm. But in space station, huge sound will be there. These are the challenges, sleeping challenges. Next slide, please. And see, this is what he is measuring the background noise, and they will try to reduce the noise so that people can have a good sound sleep in the space station. Next. Every time they have to monitor the noise. This is an interesting thing where we call it as a space toilet. Generally now, see, any space technology, there are spin-offs are there. Our like those who are wearing shoe now, jo Velcro shoe bolte na. Velcro is the space product. They say that, like that pen wala bolte hai, space pen. Like that, so many are there. Nazivian, if you have seen, जब भी cold होता है ना, you will use Nazivian to remove the blockage of nose. That was first used in the lunar program, Apollo mission में. Astronaut को जब nasal बंद होता था use करते थे. Like that, space technology, whatever we did, should come to us. So there are beautiful toilets. How many of you have seen toilets in aeroplane? None of you might have expected that the toilet will be in your house. I have never seen anybody house having a toilet which is similar to aeroplane. Nowadays some advanced toilets are coming where we need to have where it is very difficult to do susu and toilet because of the low gravity. It spills over everywhere, so you have to carefully do it. I request, please watch the Sunita Williams video. She explains, being a woman, how to do susu toilet in a space toilet. Next slide. Recently Japan has supplied to the space station new toilets. They are installed. You can have a look at it. So I was telling about the how to time pass there, because you cannot do always experiment. In our home also we will watch TV, we will watch movies, we go out, we enjoy it. But in space station, that sickness will be there, what you call as a loneliness will be there. So there is one particular window called as cupola, where astronaut, this is a Piggy White and this is Thomas Pesquet. He is playing his saxophone. She is doing photography of her interest, like that. This is also important. They will also have a specific time slot to talk to the ground friends and family people. Half an hour, 1 hour, they will chit chat. Some videos will be sent to them. Movies will be sent to them. Internet will be provided. You should also have this kind of other one regular. Otherwise, they will become mad. Next slide, please. Maybe I'm coming very close to it. Space food is very, very important. You cannot eat like हमारे तो साउथ इंडिया में हम ऐसे खाना खाते हैं, ऐसे सभी खाते हैं. So if you ask a military man, हमको गालियां देता है, sir you should eat like this sir, you don't know table manners and etiquettes. क्योंकि military में ऐसे खा के तुरंत गन पकड़ के भाग जाके they can work. For astronaut you cannot do like that. It's like just swallow things, either tablet or kind of a bar. Of course recently they have a hot water, take a hot water, just dip into it and eat it. So many space foods are available. You can have a look at it. In India also there is a Defense Food Research Laboratory. They are developing. CFTRA is there in Mysore. Next slide. So food is essential. It should be ground. All foods will be tested. Once it is tested only they will send to the space. Before eating here also they will eat the same food. Otherwise, say same date manufactured, same expiry date. One person should consume food on the ground when they are also eating it. Otherwise कुछ गड़बड़ हुआ तो कैसे उनको ट्रीट करें. So every act on space station is replicated in the ground. Next slide please. So maybe you will be surprised, left वाला paste जैसा लग रहा है. It is not a paste, it is an apple juice. Right side you can see how they are sharing the food. It is not easy. There is on Sunita Williams how to drink water. हम तो घर में ऐसे ग्लास लेके ऐसे पी सकते हैं. In space it is not possible. Bubbles will be floating here. You have to swallow it. Next slide. This is a space agriculture. Last 5-10 years, it is booming up. Many experiments are being carried out. They have grown tomato. They have grown what you call mooli, radish, carrot, then some other what you call the lettuce. जैसे पालक जैसे होगा, like that. We may go to the next slide. Space agriculture is really booming up. how to do it. See, we cannot have a soil similar to soil what we are having. You have to have a clay natured soil where it can hold the moisture. They plant the seeds, they grow it. Plant habitat is the one beautiful concept is there. I would request the students to take this as assignment. What is plant habitat in space station? What are all the plants they have grown in space station? 1 page, 2 page write up you can start writing on its space agriculture. Why you should do agriculture in space? इतना धरती के ऊपर जगह है, पानी है, fertile soil है. But if you go for a longer flights, as I told, Mars, beyond that time, you cannot carry huge kgs of food there. People are thinking to grow, which is easily consumable, less waste creating things. Okay, next slide. There is a this is a how to create a zero gravity. All of you are familiar with the Newton's thing. When you are rotating a ball, you will feel the force balancing, and then you can experience the zero gravity. There is a plane. Next slide. There is a Russian company is there where you can pay money, go there, sit in a flight. It will go in a parabolic shape. When it is coming down as a free fall, that time they will experience. Because of this reason only, if you want to become an astronaut, it is essential that you should be a pilot. Nowadays, that rule is relaxed, but they may train you in this free fall exercises where you will undergo a lot of gravity, zero gravity experiments. This is a beautiful concept, parabolic flights, where you can experience the, that's the reason in India we have selected 4 test pilots who are more than 300 or 3000 hours of flying experience. Generally, flying experience is must. Nowadays in US, a common man also is going 90 plus years person also has traveled to the space. In future, every person should be able to travel as a space tourism. Next slide. This is the same thing, which I'll skip this one. So as a part of the parabolic flight, this is how it looks inside. I think one of our ISRO scientists, Suresh Kumar, who was working in MCF Hassan, he has done this experiment. I don't remember any other than current the designate astronauts. Next slide. And once you become an astronaut, there are rigorous training. One of the training is, by mistake, if you land elsewhere, how to survive yourself until a rescue team comes to help you. So they have to have a sufficient food, they have to have a sufficient oxygen. If they fall in an ocean, they should be a good, how to swim, then rescue yourself and send a signal to the rescue team so that they can come and rescue. Next slide. If you fall in a jungle, deep jungle or deep caves, there also you should be in a position. These are all the rigorous, very tough trainings will be given. Those wish to become, aspire to become an astronaut, these difficulties, remember it. If you pass these difficulties, one is a flying, another is a swimming, another is a difficult terrain and difficult living conditions. Analog astronaut, this you can skip it. This I have already explained how to sleep in the space. Survival trainings, deep inside the ocean or a swimming pool, you have to do a survival training and the extravehicular activity training. These are all the basic trainings which they give it to an astronaut. Go to the next slide. Yeah, simulation trainings will be there. How we become a driver, no? Simulation drivers will be there. Same way simulation is there. I have exceeded my time. Kindly excuse me. I will finish it in a 5 minutes. Next slide, please. Yeah, some experiments. I told you, the one interesting experiment is there. The spider experiment. They wanted to test how spider will wave its web in space. Mostly it is similar to what they have done in Earth. That's the conclusion of that one. They have a muzzle testing experiments. Then rat, what you call embryo, they have taken to space and they have brought back and they have seen their life. Next one, except what you called the birth of a baby in space. Except that experiment, don't mistake me. That particular husband-wife experiment and giving birth to the baby in space, all experiments have been carried out. Growing agriculture, sending small mosquitoes, sending some animals, all have been tested. More than lakh of experiments have been carried out. Go to the next. This is one interesting, I have come to end. This is very, very important, that how does a fire looks in space against the ground. This picture itself will explain. Why do you need to know is, suppose in space station fire accident happens, how does the fire spread? There is a beautiful study reports are there, you can study on it. If you know the fire, I can design an extinguisher. So to design a space extinguisher, there is another area where those who are interested in space extinguisher, they can study that. So this is how it looks during microgravity and during the Earth. Maybe at this next slide, maybe last slide, it looks like that. This was my Kannada book. Of course, it is available in English also. on Amazon. Same concepts have been covered there. Next one. I think I have taken more than 10-15 minutes more. I ask excuse for that. However, at this point of time, there are so many things are there to discuss about space travel. I would be very happy to discuss in question answer session. I say my sincere thanks to Manish, who is a very dynamic and very young, talented scientist, as well as a space science educator. Actually, he's a very good at explaining physics concepts. Thank you for giving me this opportunity for giving an online talk. Other DIT authorities also express my thanks. We can have a short discussion, maybe QA sessions. I would stop here and over to Manish. Only one small last disclaimer is, please do not refer any facts and figures which I have told in this talk. By chance, if they are wrong, cross-verify in the internet, NASA website or authentic website. If I have told wrong, please communicate to me. Don't say that ISRO scientist Srinath told. That's why this like that. This is a awareness program. If you want specifically, we can have a discussion on specific aspects of any what you call scientific things. It's an overall talk which I would like to give. Please verify the facts which you have heard from my talk. Then proceed. You are also equally scientist like me. Thank you, Manish. Over to you.
Thank you, sir. It was really interesting and an amazing session. And we have so many questions. I'll take few because we have crossed the time. So the very first question is future opportunities and scope of work in space sector. So I'll combine this question and there is one more question. That question is, how first year mechanical students start their career in space sector. So means we can have a general question where you can guide students about starting their career in space. So there are many questions related to that.
Yes, definitely. When we say space in India, for last few years, ISRO was the only opportunity. Now, after the space reforms, there are many space startup companies are there. Anant Technologies, Skyroot, Bellatrix, Pixel, Digantra. Please just Google it saying that space startups in India. They are also hiring. ISRO has around 16 to 19,000 manpower. Every year, roughly around 100 recruitments will happen either in January, December time. All branches of engineering and sciences are eligible to apply for it. There is a good scope, of course, because of recent what you called Chandrayaan 3 and Mars mission. No, huge aspirants are there. Competition is more. However, I have seen many people successfully writing ISRO exam. If not ISRO exam, you can join to the various startup I have recently mentioned. There are some people who are doing some science graduation. They may end up in astronomy, astrophysics. Those people also can go to the various countries where they get an equal opportunity. Last week, one of our friend student, Panini, who got NASA's Marshall Space Center Award also in astronomy, astrophysics. Those who aspire to do astronomy, astrophysics in India also good opportunities are there. We have Aditya, we have Astrosat. In future, some space missions are coming up. You can work as a professor somewhere and do space mission data analysis. If you want to join in space industry, you are welcome. But only thing is competition nowadays is increasing. One job for 1,000 like that. All ratios are there. But nevertheless, there is a good scope. Apart from that, HAL, NAL, certain aerospace industries are there. DRDO is there. Many space and aerospace companies are there. Please keep yourself optimistic. Don't get discouraged that I didn't get in ISRO somebody. Please, not like that. Even I was I don't know whether today if I write exam, I will qualify ISRO or not. It all depends on that day. It's you can definitely qualify. And for mechanical engineers, definitely good opportunities are there in future. That you should do controls, guidance, such kind of subjects. Huge number of mechanical electronics engineers are more in ISRO. Up to maths, even maths so graduates are also being recruited. Over to you, Manish. Next question.
Yeah, sir. The next question is: it says that as sir, you have worked in SpaceX and you are working for Gaganyaan. Can you please provide some details about the progress? Means I think the student wants to know where right now we are and what to expect in coming future about the SpaceX and the Gaganyaan mission.
SpaceX is a docking experiment to demonstrate the capability to have two missions docked. Like I told, International Space Station, there are docking ports. So that is a technology which India has to demonstrate it. We are doing good work in that. Maybe very soon we will have that mission will be launched. Compared to Gaganyaan, you have seen in recent newspapers that it is progressing well. Two astronauts have been shortlisted to fly in ISS. Very soon, our own astronauts will fly from our own Sriharikota also.
Okay, so the next question is again related to Gaganyaan only. The question says that we are developing our own ECLSS for the Gaganyaan mission. So, what's the status? Okay, again, general thing they are asking about the ECLSS because that is a very critical component of a crew
Not
mission.
only ECLSS, many Gaganyaan related technologies have to be developed within India. People are working on it. It is in good progress. Hope to see future our successful Gaganyaan mission. Maybe
Okay,
those who do not know ECLSS, we have to tell that environmental control and life support system. That is a very, very essential thing for any manned mission. Next question.
most of the questions that are coming, sir, are related to the career only. How to make a career in space science. I want to do research in ISRO. How to approach? What are the opportunities to do research in ISRO? What
Yeah.
is the scope
So
for?
generally, I'll try to tell. For example, for in astronomy, we have Chandrayaan 1, Chandrayaan 2. Very soon, Chandrayaan 3 data also will come into public domain. And you have a Mars mission data. Then you have our AstroSat data. And ExpoSat is also going to come into public domain. There is a website called issdc.gov.in. If you are in Google, just put ISSDC plus ISRO. It will direct to isdc.gov.in, where you can create your own login and try to look for Chandrayaan data, whichever satellite data you want, you can download. This is generically downloading data and doing research. If you are a MSc or a research student doing PhD, if you want to do it within ISRO, there is a respond program. Go to ISRO website, isro.gov.in, where you can submit your proposals. And even for the AstroSat, we are allowing research community to submit their proposals. We call it as announcement of opportunity. Currently, A14 is getting ready. Maybe A15 very soon we will announce where you can submit. In spite of that, there is a target of opportunity where people can directly submit using our AstroSat proposal system, APPS, where you can submit your proposals and we will accept it, observe the particular target and give you the data. You can continue your research. Every alternate 2 days we are getting so many proposals from academicians who are doing astronomy, astrophysics research. Engineering side also a lot of scope is there. You can have a look at it on ISRO website. There is a technology segment is there where a lot of reports are available in ISRO website. Please read it. You will definitely get an idea about your own domain.
Okay, sir, we will take one more question because this question is from a student who has, I think, given a very specific interest on the details that I have read about you, because the question is about satellite tracking. What does it mean when we call satellite tracking telecommand? What does it mean?
Yes,
This is a very
yes,
simple question the student
yes.
asked.
Yeah, recently SSLV D3 was launched. Okay, if you have seen in television when the launch was happening, all parameters are displayed till the satellite is injected. That is the our job starts. What we are saying, of course, during launch also our ISTRAC, our center will support it. Generally, satellite tracking is only question is asked. The moment satellite is injected, from that point till the end of the mission, it will be in the orbit. You have to maintain it in the orbit, operate it successfully, use the what you call payloads to collect the data and download the data. So that entire activity will be done by ISRO Telemetry Tracking Command and Network Station. We call it as ISTRAC. We have 11-meter antenna, 7.5-meter antenna, up to 32-meter antennas are there all over the world. ISRO is spread all over the world. Wherever the orbit goes, we can definitely track it. We need to monitor its health. We need to operate its payloads. That is the overall activity of ISRO tracking telemetry and command network, where mechanical engineers, electronics, physics, maths, and many other diploma. Even I have many people who have done ITI and MEI, all are working, all cadre people are working, up to MTech PhD people also. It's a set of all kind of people who work 24/7 taking care of our ISRO's assets in space.
Okay, so that is all, sir. Thank you so much for your valuable time, and it was really an interesting, intriguing session, and we got a lot to know about the intricacies of human space travel. And I hope students have also loved it. This whole session has been streamed live on YouTube and different other social media platforms, and students have been watching this through a webinar or a seminar hall also. So many students are right now watching this session, and it has been a great experience for all of us. Thank you, sir.
Thank you, Manish. I will leave the room.
Okay, thanks.